In this new video series, we are going to study and understand what is a microcontroller. You should be able to understand what is a microcontroller, understanding the architecture, the development environment, and the programming side of a microcontroller, its input and output, and everything that is required for you to know about a microcontroller. So I believe at the end of this video, you should fully understand what is a microcontroller. We should start by defining what is a microcontroller. A microcontroller is defined as a compact integrated circuit. And in the figure given, we have some examples of a microcontroller chip or the integrated circuit that is available in the market. We have the Atmel AVR, Atmega PIC 8051, Arduino ARM, and there are other microcontrollers that are there, and they mostly perform a function which are mostly common to every of these microcontroller. However, they may have different integrated development environment for each of them, and most of these microcontrollers, they are designed to perform a specific task in an embedded system. If you can think of any task you want to perform, a microcontroller can be able to help you do that. Imagine you want to measure a temperature. We mostly feel the temperature, but we don't know the value of the temperature. In order to help us solve this problem, now this temperature value is our specific task. So our task now is to find the value of the temperature. Imagine we have MCU, which denote a microcontroller, and we want to display the temperature on a screen, and this screen can be the LCD, and we can measure the temperature through a temperature sensor. We can have LM35, which is the part number for a temperature sensor, and this microcontroller is responsible to perform this task. It will now read the temperature and it will display the temperature for us, and also it can perform other actions such as controlling a cooling system. So all of this can be regarded as a task, and these tasks need to be performed. Therefore, those type of microcontroller that we have can be able to perform this task. And it is also defined as a computer on a chip. So those microcontrollers, they are a computer on its own, where it contains the central processing unit or the CPU. We will later explain the CPU, and also the memory and the peripherals such as the input and output, the timer, the analog to digital converter, and the communication port. So all of these functions are embedded inside a microcontroller. And the microcontroller itself can be regarded as a controller. And if you later want to build any form of project where you require automation or a specific task you want to achieve, you can be able to choose a microcontroller. And before you choose a microcontroller for your projects or your studies, it is also important that you know how the microcontroller function and how it executes the instruction. Before we dive in, we're now going to look at the basic component of a microcontroller. Let us now discuss the basic component of a microcontroller. The first component of a microcontroller is known as the CPU, or the core of the microcontroller. So what the CPU does is to execute the instruction. Therefore, it can also be regarded as the brain of the microcontroller, because in order to perform a specific task, there should be an instruction embedded into the microcontroller. And the CPU, in most cases, it is called a microprocessor. So from this diagram, we have a microcontroller, and the microprocessor is inbuilt into the microcontroller. And this microprocessor is the brain of the microcontroller. Therefore, it is called a central processing unit. The second basic component is called the random access memory. A random access memory, sometimes called the RAM, it has a function such that it will store data temporarily. Any data that is needed to be executed will be stored temporarily in the random access memory. And random access memory is a memory called a volatile memory. When there is power in the circuit, then it can be able to store the data. And when the power is switched off, all the data will be vanished. And thirdly, we have the read-only memory, and it is called the ROM, and it is also a memory circuit. And what the read-only memory does is to store the firmware of a microcontroller. Remember, if you have a computer and without any operating system installed in your computer, and if you switch on your computer, you will see a boot mode, and this boot mode contains the firmware, because in a read-only memory, it is a non-volatile memory. That means whether there is power or there is no power in the circuit, the data that is stored, example the firmware, won't vanish. Therefore, it is called a non-volatile memory. Therefore, a read-only memory in a microcontroller will store the firmware of the chip. And D, we can have the flash memory. So a flash memory is also a circuit, and this flash memory is a memory that is used to store the program, or we can call it the instruction. If you want this particular microcontroller to perform a task, then you will program this microcontroller, and this program can be regarded as an instruction, where you are now giving a certain instruction for a specific task to a microcontroller, and those instructions will be stored in the flash memory. And the other basic component is called the input and the output ports. So what is the input and output port? If you see from any microcontroller, you will see the pins, and those pins comes with a label, and they have a specific function, and most of this function is to connect the peripherals, and we can call it the external devices. And those external devices or the peripherals can be the light emitting diodes, some sensors, some switches, display, and etc. So those ports will help us to interface other devices, so that information can be shared between the microcontroller and those devices. And those input and output port on a microcontroller can act as an input port or the output port. And some microcontroller contain many different ports, and they have specific function where we will discuss later on. And the other basic component is known as the timer or the counter. So what is the function of the timer and the counter inside a microcontroller? So the timer and the counter, they are called the time-based operation, and those operations are like the delays and the interrupt. If you want to delay the instruction to be performed inside a microcontroller, then you will use a delay. And if you want to interrupt the program or the instruction in a microcontroller, then you will use the function interrupt. So the counter and the timer, they are a set of function that is available in a microcontroller, and they play an important role in how the instruction is executed inside the microcontroller. And the other basic component is the communication interface. So what is a communication interface? In a microcontroller, we have communication phase such as the UART, SPI, I2C, CAN, and etc. When we talk about the communication interface, we are mostly talking about how the data can be processed or a data that can enter and leave a microcontroller. We know communication protocols such as serial data transmission, parallel data transmission. All of these can occur in a microcontroller. If we want to send a serial or a parallel data in and out of a microcontroller, we normally use the communication interface. And finally, we have the analog to digital converter or digital to analog converter, and these are the abbreviation for ADC, meaning analog to digital conversion, and DAC means digital to analog conversion. That means if we want to convert analog signal to a digital signal, then we normally use analog to digital converter. Now if we want to convert a digital signal to a analog signal, we now use the digital to analog converter circuit. And this analog to digital converter and digital to analog converter circuit are built inside a microcontroller. Therefore, they are now responsible for convert analog signal to digital or vice versa, like I have explained. Those are the main or the basic component of a microcontroller. To fully understand a microcontroller, it is important that you know all these basic components. All of these components is very handy when dealing with a specific task. And without prior knowledge to all these components, it will become quite difficult in analyzing the overall function and the ability of a microcontroller to perform a specific task. Since there are many different types of microcontroller available, the basic component is consistent throughout. Every microcontroller, you will find those components having a specific function inbuilt of a microcontroller. And to understand microcontroller, if someone asks you what is a microcontroller, you can explain a microcontroller in terms of the component of a microcontroller. You can be able to explain that a microcontroller have a CPU known as the microprocessor, and it has the random access memory, and it has the ROM, and it has the flash memory or the program memory. It is having the input and the output port like the one we see here, the pins, and we have the timer and the counter which is inbuilt, and we have the communication interface and analog to digital converter circuit or the digital to analog converter circuit. All microcontrollers will have this basic component. So I believe with this explanation you can fully know what is a microcontroller. Now we can also discuss the key characteristics of a microcontroller that makes it so unique. The microcontroller is unique such that it is of low cost, where you can buy a microcontroller for very small amount of money. And also a microcontroller have a low power consumption, where most microcontroller they operate on 3.3 volts or 5 volts, where the power is very small. And we can say some of the key characteristic or the main characteristic of a microcontroller is it is small in terms of the physical size. So it has a small physical size, and we can say it has a real-time control capabilities. Therefore, most of this microcontroller can operate on a real time, same as how our brain operates in terms of the real time. And most microcontrollers that are built nowadays, engineers are willing to design a microcontroller that are very small, where some of these chips can be very small as a grain of rice. And most of these can be used in embedded system. We have some smartphones and some smartwatches which uses some of the chip which is very small in size. And those type of microcontroller, they describe the key characteristic that most of these microcontroller will have. Most engineers nowadays, they are trying to minimize the size of the microcontroller so it can fit into different embedded application. And because it is very small, the power consumption will also be reduced. And because it has a low power supply, we can have a microcontroller having a 5 volts or 3.3 volts that will power all the operation of this particular microcontroller. And because this power supply power the chip, all of these functions such as the memory, the CPU, all of them will get the power from the 5 volts or the 3.3 volts power supply. And some of the pins, they can also source a power to the external devices or the peripherals such as the LED, some display. This microcontroller can be able to regulate the power supply. Thank you for watching our video. Kindly subscribe to our channel and share this video with your friends so they can also be able to learn